Thanks again for everybody joining us today. This is sort of our second go around for IMS, and we did a PowerPoint on this earlier, a webinar on this earlier, but it was a bit of a limited release, so we thought it'd be a good time to do another one. And as I have on my notes on the screen here, I plan to do a bit of a webinar series this year for 2023, and ideally I'll be looking for doing one a quarter. And so I'm cramming these two in here because we're already into Q2, and we're going to do a Simco Probe webinar, and that's set for May 12th. It'll be the same time, and so keep an eye out for that. There'll be an invite, and then moving forward, we'll ideally have two more webinars, Q3 and Q4 as well. So a little bit of an intro on IMS software as a whole. IMS is by no means a new product. It's new to us. We've had it for a couple months now, but the product itself has been around since 1989. And the idea, what it does in a nutshell, is it's full G-code simulation and verification embedded in Mastercam. It's support for all major control manufacturers and models. I have a list on the next page. I'll show you what those are. And most importantly, the integration inside of Mastercam. Because it's been around since 1989, it also integrates into CATIA, NX, and 3D Experience as well. And so a key feature there is there's no need to leave the CAM environment, which I know is pretty key for a lot of folks. So a little bit on the controller families that we have: Fanuc, Siemens, Fagor, Heidenhain, Mazak, Haas, Okuma, NUM, Fidia, and Mitsubishi. So just a few, I guess, key points and advantages on IMS as a whole, and everything that I talk about here, it's obviously just a brief summary. David is going to dive into on the screen and show all of this, so I'll kind of just lightly scan through here. But essentially, it's complete emulation of the G-code. So that includes subroutines, support for controller variables in expressions. All motion is checked, so controller subroutines, probing, can cycles, and motion introduced by post-processing. Syntax, logical checking, so cutting without coolant, spindle motion, consideration for absolute and incremental motion as well. And then just some key points here, the Mastercam integration. So you can see I've just got a screen grab. David will dive into this a bit more as well. You basically get a ribbon bar at the top. It joins in with all the other ones you're used to: model prep, mesh, drafting, and then you've got your IMS here. So moving on with that, what's important is the ability to pull the master model, stock, and fixture that you have already set up within Mastercam. So it's the same formatting as Mastercam NCI machine simulation. Some of you already have machine sim, so that's nice. And again, David will touch on that in his presentation. There is an upgrade route for folks that already have the machine simulation, so that's nice as well. And then, so the ability to scroll through each line of code, able to bookmark that code to review, output report, and then track axis movements. Then I've got a couple other points over here. Not, I wouldn't say more importantly, but pretty key is the fact that this product is competitively priced. And of course, you get support that everybody's come to know and love from in-house solutions. So that's pretty awesome. And I think, if I'm not mistaken, that's on to you, David. So we can go ahead and flip off our webcam so that we can focus in on the presentation aspect, and you can go ahead and grab the control as well.
Okay.
Yeah.
You can see my screen now?
I can see your screen, yeah, and
okay.
Looks like it's covering the whole thing, so we're good to go.
Okay. So this is the first part here that I have for a demo. It's a nice little 5-axis part. So I'm just going to take you quickly through, and we'll do the verification quick. So it's in the toolbar up here, the IMS software. So we just need to select the fixture, the stock, and the workpiece. So we'll select the fixture. We can do level picks right off the level itself. And then the stock, and of course the workpiece. And then we can go straight into simulation. It's that easy. The defaults, you can set. Once you've set, you can save the setup kind of thing. Your machine and your controllers can be set as a default path, so you don't need to continuously set all this stuff. But this will take in, and you can see how integrated it really is into Mastercam. It's actually taken hold of their simulator and running the G-code through the simulator, which is fantastic. You can scroll the G-code up and down with your mouse, which is really neat. So I'm just waiting for this to load up now. Let's wait for that to load up. Okay, so we have that full. So the first thing I'd like to point out to you is that the machine comes in like this. We do have the full machine in there. I mean, it goes down to coolant pump and chip conveyor. The only reason why it's off is because we need to see inside, so we'll just shut it off for the verification itself. So we'll call up the move list, and we can display the CNC program right here. If we click on an operation, we can fast forward the simulation to it. So I'm just going to set up so it changes colors to the tool numbers, and then we'll go back to the CNC file, and I'll just let this play, and you can kind of see what you're going to get here. Now, keeping in mind, you can stop at any time, and you can backwards and forwards through it. So we'll just speed this right up. So now it's finishing the faces, face by face, around, and you can see every one of the movements that's happening on the machine itself. At any time, you can pause the machine, and you can zoom in and see it better. You can, like I say, you can scroll back and forth. If we want to click to the next operation, we can just do that, and it'll fast forward it. Keeping in mind, it takes a couple minutes to get through it because there's 337,000 lines that it's going through right now. So it takes a couple minutes to get through this. Of course, you can let that play to it, but if you want to be quick about it, you can verify it this way and get to your next operation kind of thing without having to look at the whole thing at the same time. So now we're at the next operation. You can see the whole outside of the 5 axis there is complete. So we'll just let this run now. We're doing helixing and finishing. And without even setting the simulation to check collisions, it's already got a collision now. And we can, for similar events in this operation, so we'll just fast forward it basically. So we'll let that play through. But you can see how it's red Xing the CNC program over here. And at the same time, it's creating a report file here that we can click on at any time. And you can go back to those. So go back to the move list here, and we can just keep on playing that. So it's catching all the errors that are happening. I'll show you why this is happening in just a sec. Just get through these errors. And then it does the slots across the top. But at any time, again, we can come back to that operation. There's your, and we can scroll through that by the mouse. So if we zoom in here, we can actually see visually what's going on. So you're cutting flutes down here, and it's actually trying to cut on the shank. But we don't need to visually see this. We can actually go to the report back here, and we can actually see here collision between the stock and tools, the shaft of the part. So you can see that why it's getting called up. So this is the basic overview of the G-code. I just wanted to show you how easy it is actually to get into it and how fast it can be once the machine's set up. So if you're doing revisions of programs to get into it, you don't need to do the whole setup every time. You can just call that and create a new CNC file and run it through. So what we'll do is we'll go back out now, and I'll take you through the steps that it would actually take to set the full job up. And keeping in mind, again, we can save this, and you can see this is the way I've called up this file. I haven't even called up, because in the file menu, you can save the setup here, or you can open it. So, but I haven't even opened it, and this already comes in. So it tells you it's already seeing it. So the machine, you'd have to set your machine into a machine directory. But again, this can come from preferences that we can set here. So you don't need to set this continuously over and over kind of thing. It's quick. So I'll just go through the whole interface of it. So again, you can save and open the setups here. So to do the actual setup on the machine, I know Vericut users will really like this because this is, Vericut's, it's an excellent program, but there's a lot of setup with the tools and this type of thing. With IMSce, it's this simple fact of just turning on the length compensation and auto-filling the tool data, and it'll automatically pull the tool data from the tool paths themselves and the tool manager and pass all those values into this. So there's really no setup. So again, for the diameter compensation, we can just click that on, and then we need to call in the table values. Again, from Mastercam, it's calling it in. So then if we go further with it, now we get into origins. So in this program, we're using a G54, so it would literally be typing in G54. If I zero these out, and I just make these 0, I just want you to see how easy it is actually. So there's defaults here, so we just set the defaults. It's a simple one-click. For preferences, this is where you could set your machine, so every time it's going to continuously look back. So if you have your machines on a network drive or whatever, and the controllers, you can have that configured right to that path already. The ISO folder changes pretty much with every job because that's your CNC file. The workpiece collision you set here, and what I'm finding, if I go any less than 2 thou, it starts catching every little detail. So you're getting into tenths and stuff like this. So it will catch every little detail, but it gets monotonous kind of thing because there's so many little tiny errors, like 1/10 and stuff like this. So I showed you where the machine and the controller set. So we'd have to actually click on and set the machine for each of these in the path. But again, from preferences, we could have that come in for us. We set up our CNC code here, so we'll just select this, and then you can select your CNC code there. For the machining 0, it's basically the distance from the 0 down to the bottom of the fixture, and we can pick that right off the screen here. And if I'm just making this an even number kind of thing, and then we can go back to it. For the actual setup, like I showed you the first time, it's really just picking a fixture. And what's really nice is you can come right off the levels. So you don't, if there's a whole pile of components for your fixture, you don't need to individually pick everything. You can just pick it right from a level. Stock, and then the workpiece. And we're straight back into the finishing, or into the setup of the IMS. One thing that I'd like to point out is if we do these view sheets at the bottom, it really helps because you can pick everything from that, which makes it really, it's pretty straightforward. And then we can launch back into the simulation kind of thing. Now I'll go over the details and some of the controls inside the simulation. But like I say, it's taking over Mastercam simulation. So there's really no learning to this. If you know simulator already from Mastercam, you pretty much have a good understanding of how to use the software. Because IMS, you basically just pick in the fixture, the stock, and the workpiece, and you'll go right into the simulation itself. And again, it's the same interface as Mastercam. So again, if you're used to using Mastercam, the simulator, it's all the same controls. So there's nothing new there. We just got to wait for this to load up. So now I'd like to go over some of the features. So I showed you the machine itself. You can turn that on and off. You have the ability to go through for the stock too as well. You can do that translucent for the stock. You can turn your workpiece on it on the inside so you can see that. One thing I'd like to point out is that if you turn your workpiece off like this, it's still there in the background. It's still checking against it. So it's not like you need to have it on to be able to check that or anything like that. So and you can turn on your fixture. They're all translucent. You can turn all the controls on and off that way. So I'll just turn the stock back on. So the rest of the menu here, so there's a material mode. So this is like what you've got right now. So you see the material coming off the stock. We can change it to backplot, which puts you toolpath lines, but it kind of goes against the simulation. I prefer to see the material coming off. You've got an NC mode and a length mode. So NC mode's like the quicker version. Length mode would be more suited towards the actual time. Your machine itself. So this is there's 3 different things you can do here. You can use the machine to simulate like this. you can go in on the tool itself, but it doesn't show you the machine movement, so I don't really like this. And then same with this one here. So the one that the tool moves around the stock, and the other one, basically the stock moves around the tool. So I'll put that back to the machine, and then we just got to shut this back off so we can see everything. And then you've got like a VCR control here. So it's pretty straightforward. There's a run, a restart, you know, and you can start on your next operation. The same controls come up here in this little quick toolbar up here. And this is all configurable, so you can change the settings or whatever you need to here. So there's a slider speed here for your speed control, and then it pulls out here. I believe that they're the same, because you can see that the slider moving up on top. I think it's the same thing. The view menu shows you all your panes up here. So these are all the information panes. All those appear down here at the bottom. And I'll get into each one of those. So there's a graphics, so you can take a picture basically of this setup. So if you wanted to capture that, you can capture that with the graphics. You can also start a video, and it would record the simulation itself. So now if we come to the verification menu, this will be your gouge check. This is very similar. This is what simulator actually uses. So we can still use this. I can't show you any results right now because we're still not cutting in the CNC file here. But once you're in, you can see the gouges and the excesses. It'll give you the amounts and everything. The apply refines when you zoom into an area and it's kind of chunky. You need to refine the view so you can see it better. You can click on that button. Then when you do come back out to full view, you can hit the reset refine, and it'll bring it back to the view that you're here now. So if we go into the file menu, into the back part of the simulator, there's information here. So it's your collision tolerance that we set. I showed you how to set that. It's telling us the tool collision is on and the proximities alert is disabled. So then we can load a new machine here. Saving the machine there if you want. You can create a presentation. This is fantastic. The only thing you need to pay attention to is a little warning here about 64-bit operating system. But this is fantastic, and I'll tell you the reason why, because you can actually set this, create the presentation, and send it to your customer. They can actually go through the entire program and check out the whole verification. It's almost like you have IMSce on your computer, and you can do the same types of things. So it's pretty neat. Saving stock material, and you've got an option to save for a different tolerance. You can create a simulation report. It'll create an XML file for you, so you can output the results or the file there. And like I say, it's an XML file. And then we've got options. So if we turn the options on here, I showed you before how it was already catching the errors in the toolpath. So we'd have to turn on the collision and gouge, and then you can show. This is basically showing you the notifications for fast forwarding. There's some miscellaneous things here. Most of it's to do with the way that the simulation appears, the thickness of the tool or the thickness of the pass and stuff like this for back plotting and stuff. The verification, we have to enable this to get your collision checking. But again, I showed you that it was already catching that without even turning this on. Proximity alerts are really good for over travels and this type of thing. Or if you're getting too close to something, it'll come on. So the graphics in the background, again, now you're starting to get into more of the way it looks. I stay away from the customization too much because I'd rather work with it out of the box, because otherwise if I move on to a next thing, you have to relearn and put everything back, and I don't like doing that. So the screen objects, so you can turn stuff on and off here. So we can turn on a measure grid if we need to. That's in the background. There's different display things for your cube and everything else. The background colors and this type of thing, your animation speed, so you can set it already, what speed you're at and everything. The customization, this is for the ribbon bar up at the top here. Or sorry, that's for the ribbon bar at the top, the quick access toolbar. And you can add commands as you feel free kind of thing. And this is your customization for the whole toolbar at the top. And you can pull this down. You can add commands or whatever you want and make the toolbar different. Like I say, I prefer to leave this the way it is, and then that way you get used to it. And then with a new version, it looks pretty much the same. For the capture, this gives you a little bit more details for the video capture and the pictures. So you can change the output, you can change your frame rates and stuff like this. So that's pretty much the back end of things. So if we go back to the view panels here, if I turn on the move list, you've got the whole CNC program here. So again, you can scroll through that anytime you want, and you can see that. The operations, you can come and you can click on any one of those. So you don't need to wait, which is like fantastic. And it'll bring us right to that part in the program. And then you can scroll forward from there. There's no limitations on when you can scroll, kind of thing. So to go a little further into it, some of these panels, each one has a different control kind of thing. So this one here controls the analysis panel. So you can set tool numbers. So it'll change the stock numbers to the colors to the tool numbers. And you can do it with operation numbers, same type of thing. There's deviation, there's height change. The two that I use the most out of this is deviation and the gouge check, or the gouge and excess, because it's very easy. And at any time you can hit this and it'll show you where you're at, kind of thing, with the stock. Right now you can tell there's a whole lot of stock still on that from the colors. So if we go back to the analysis page, now that we've actually got some toolpaths on the screen, if I turn on the simulation, if I turn on the toolpath now, you can see all your toolpath lines. So those are all your toolpath lines that, you know, it took to take those steps, kind of thing. With this here, you can go in on operation numbers, operation highlights. You can do B-axis values, so you can see where your B-axis values are and how it applies to the graph. There's a lot of information here. I don't want to go too far into it, but you can do feed rates, collisions. There's a lot of stuff you can see in here. This is great information. There's a statistics panel, so we can, and I'll just shut off that toolpath. So the statistics panels gives you all the things you'd expect. The tool tip position, the operation, where you're at, how many operations are to go, kind of thing. Everything's there, the min and max. The simulation panels actually are pretty good, because this one here, you can turn on and off your tool changes. So if you wanted to stop on a tool change, you could do it here. Same with an operation change. They really give you some good options here. So there's some block. You can do it off of block numbers. You can do it off of bookmarks. So if we wanted to do it off of bookmarks, we could just turn that on. And it's really simple. You just create a bookmark. So create a bookmark there, and then it would automatically and stop on that part in the program. So you can fast forward, create your bookmark, and it'll stop on that point, which is great. So go back to this. If I turn that off, you can do it off of the new this chip detection too, and also tip values. So there's a lot of possibilities that you can sort of stop the tool at and go through. You don't need to necessarily see the whole thing to be able to catch everything or see it again. And then there's a report page that goes on. So these are where all the collisions were showing up. In the background, there is a machine page. This is literally the machine, how it's built, all the components for the machine. So all the back stickers, the conveyor, all of it's on. The CC1 is your collision checking. So and it's telling me so we're checking right now the tool against the fixture, the stock, the initial stock, everything. If you do, for example, you can add collision checks. So for example, if you had an extra coolant hose here or some kind of extra attachment or a different fixture, you could add that in to your machine, and we could do a collision check on that as well. So if there is stuff around the spindle and you're worried about it around your setup, you can easily add a collision check to make sure your tools aren't going to interfere with this type of thing. So this is pretty much this whole demo, but it gives you all the nice, and what's really nice about this is you actually see the live movements. That's what I really like about it, because that was something that was a big complaint of mine, programming 30 years, and you don't really see the in-between moves. This is very clear about that. So you can, and at any time, it's beautiful the way you can back and forth this way. So I'll escape out of this demo now, and we'll go on to the next ones. I got a bunch of other different machines and different demos to show you. So I wanted to show you next is we've got a multiple origin one. So now, because I figured there'd be questions, can you use multiple origins? So this is a horizontal machine we're using, and that was the previous one was a ICOS. So this setup here is using multiple origins. I'm using 54 all the way up to 57, and labeled up there, as you can see. We're using a Matsura H plus 630 for this, so it's a horizontal. What I've done, I've made the G54s right there in the planes. So if we launch this straight into simulation, but the one thing I wanted to point out with this is that the whole point of this exercise is to show you that you can use multiple origins, and they don't always have to be in the same spot. So if you can see, each one of these stalks is in a different position on the cube, so you can tell if there's a problem or anything with using multiple origins. That's why I did this. I wanted to show you that you can actually use it and it's successful. So in the origins part of this, you'd have the multiple origins. And again, same thing for this. You can literally just click here and hit the defaults and it'll fill all those numbers in for you. The only thing you're meant to do is just put in the 54 through whatever numbers you're using and then hit the defaults on it. So we'll just do this, the setup now for this. So we'll finish this off. And again, what's really nice is you can come off the levels here. So we can do our stock right there off the levels. We'll finish picking that and we can get the parts in now. Oops. What's going on with that? Okay, we'll do this a different way. And finish picking that. And then we'll go right into the simulation here. On this particular one, I wanted to show you, so there's multiple origins, and also at the same time, we're using a subprogram in this. I wrote it myself just to show you that you can use a subprogram in it. So when that's running, I'll show you where the subprogram is inside the G-code. We can actually watch it run. So I'm just gonna launch this straight into verification. The origin or the machining 0 on this one, because we're at the bottom of the cube, you just leave it at 0. We don't need to set any information there or anything like that. So again, this is the whole machine. So this is what they've chosen to sort of look at when you're seeing the verification. So again, the whole machine's still there. It's not like it's not there, it is. So we can turn that back off now. And we can let this run. And we've got our move list here. So we can just call that right up on the screen. I'm just gonna color the tool so you can see it here proper. And we'll slow that down a little bit. We can just let this run. Speed that up a tiny bit. But you can see the multiple origins now. And you can see them over here too as well. So as this comes up, so I'll just let this finish. So it does 2 finish passes around the outside of it. And then you'll notice down here in the CNC code, there's your actual G65 for your P. So there's your subprogram there being called in. And then it returns to the main program there. And now our next origin up would be 55. So now it flips the cube, goes to and we're going to get the same type of program again. It's a little rough around the outside. And then 2 finish cuts. Okay, and then we'll go through this and we can see here, there's your subprogram again, and then back to the main program. And now we're at 56 now. So I'm just going to let this finish up now. But you can see using multiple origins is not a problem. Okay, and we can double check everything now that we've got this. So we can come back to the analysis page that I showed you, and we can go to deviation, and we can just hit the button there. And we can see there's no deviations in that at all. And this is being checked to that 2 thou tolerance that I set inside the setup before we came into simulation. So you can change that. And that'll be set there. And then, like I say, if you want to change that to 1 thou, it'll start catching every little detail. So that's one. I just wanted to show you the next setup, and you can do multiple origins with a subprogram, which is kind of neat. And then again, you can back this up at any time and go backwards. What's really cool about this is if you do happen to write anything manual, you can actually run it through this to make sure you're good. So we'll kill this and we'll go to the next one now. So this is an interesting part. It's back on the Ike of the Haas UMC 750. So nice little part. Oops. All 5 axis. So we'll do this, and I'm going to go right into the you can see how easy this is. So in this one here, it's actually saved all the stuff, but I'll just re-pick this. So for fixture, we can screen pick if we want, and then stock and workpiece. And then again, the machine's set, the controller's set, and I've got a NC file. So now we can just go straight into verification. And again, this is saved in the files. And you see that I didn't even have to say file open to get the setup, and it's there. And this opens up so we can clearly see that. And we've got our CNC program. So we're just going to let this run. I'm just going to color those tools again for operation number, and we can let that run. What I'm going to do is just speed it up a little bit. And one thing I forgot, I'm just going to go back here, and we're going to turn on this collision. So I'm going to turn on the notifications there, and I'll turn on the collision here, and then we can let that run. I'll turn that colors back on. And we can get that CNC program out so we can see that. So it's pretty detailed, and of course at any time you can, stop and zoom in and everything. And then if you do want to see something really particular, you can go in to see the fine details kind of thing, and backwards, whatever you need to do there. So we'll just let that run a little further. Okay, so we do have a bit of a problem with this. So there's a collision now between the tool and the workpiece. So we can, I showed you this for all similar up. If you don't, it's just going to keep on displaying this collision message over and over again. So we'll just skip by that. So it'll skip by all the notifications for that operation. And you can see it in the words there. It actually says in this operation. So if you choose the other one for all gouges and collisions, it'll skip them all. But again, it'll still show up in your program and in the reports. So even if you do skip it, it's not like you miss it kind of thing. You can bring it back. So we'll say okay to that. And then we'll go back and take a look at the details of this and why it's stopping. Okay, and this has gone all red too. I've noticed this. So there's a few things going on with this one. So we can go back to the report here. So we can see the collision first to this one here. So there's something going on with this tool on this face. And we can see it's a range between 2 and 4 thou. So we're just going to check that, and we'll check in a little bit more detail about what's actually going on with this. So we check the deviation. You can actually see the deviation going on here. So something's wrong with that swarf cut in the bottom there. So that's one. And then if we go to the next ones, it'll automatically bring us to that point in the program. And again, the CNC file, it brings you right to that point in the CNC file. So this one here, I believe what's going on is it's going around the outside. I think it's trying to do like a 45 on that rad, and then that's a problem because it's not on the actual model. So we'll skip this one, and I'll go on to the report at the end here. I wanted to show you this one because this is how accurate this thing is. If it's stopping on these chamfers around the outside, because we've programmed in a chamfer all the way around here, but if you look at the actual model, there is no chamfer. So it's stopping on those chamfers and catching every one of them, which is like really, it even catches chamfers, right? So you can see, and again, you can go back to the CNC code at any time and you can forward this and you can see the actual movements. I know for a 5-axis programmer, this is amazing because you see the actual movements on the machine. There's many times when I've gotten errors on the screen and you're really wondering what's actually going on. This will actually show you, you can run it and you can actually see what's going on. So you're creating the error just because you're trying to put that chamfer on that and it's not on the model. So that's a problem. Okay, so this is pretty much this verification here. I just wanted to show you that it will stop on different things. And you know, it shows up here in the tool paths. and in the report, which is fantastic. There's log files to get output with this too. So you can see the log file itself, and it'll come up. I'm just trying to. So in this one here, because this was the Wankel assembly that we did the first verification, so there was no errors and warnings when I ran this. There was after I changed the flute length to create an error. So you would see the errors and everything, but I did want to show you that it outputs a log file. It also outputs it's almost like a little setup sheet that it does for you. So you've got this as well. I prefer Mastercam setup sheet, but I just wanted to show you that you can do that if you want. So we'll exit out of this verification, and I have another one for you now. So we can go on to another one here. So this one here is a little form block that I did up myself. It's a little 4 or 5 axis job. So I designed it myself. I just wanted to do like a quick demo to show you. The machine goes squirrely on the verification because you can see it trying to meet all those angles and everything. So again, just calling the file, I haven't opened this part here, and already this stuff's here. So the machine's already filled in. Your control and your NC files already still there. The setup's already still there as well. So origins are in place. And again, it's the same type of thing. We don't need to go into this whole big long detail. It's really just a mouse button click. So you'd have to set your G54, one mouse button click and say okay. And then once you save it, it'll always come back for you. The length again, so you'd have to set your length and your diameter, but you can see how it's all set already from the call up of the. So now we'll just go into the selecting the fixture, and it's so nice off the level that you can just click the levels and it comes up on the screen there. So we can select our stock and our workpiece. And there's the value there. And again, it's the number from there to the bottom. So it's already set. We don't even need to do that. So we can go right into simulation here. So the nice thing about this is with Vericut, there's a lot of setup to it. The tools to set that up can sometimes take hours. I've seen it take longer than what it does to create the program. So this is the bonus part of the IMSce, is that it's pulling that information from Mastercam. And if you update flute length, like in that first job, if we were to update that flute length and then repost, you can get that immediately. So the stock. So again, we're back to the same controls again. So we can output the CNC program here, and we can just go straight into it. I'll just color that again by operation number. We can turn that on. And nice, you can stop any place you want kind of thing. And I'll just let this run because it's really funny to see the machine sort of going back and forth, going crazy. But it shows you the whole point of this is to show you the machine movements you get on the machine. So you can, it's very detailed. So you can actually see what's going on. So if there is a problem with the machine moves, like if your table, your C-axis is swinging all over the place, you're going to see it here, which would really give you a good indication you're probably going to get a gouge in that area. So we'll just let this go through, but it's neat to see the machine movements. That's the one thing that I really appreciate about this and what it's doing, the in-between moves. And again, we can call that up on the, so you know that there's no trickery going on. It's reading the actual G-code itself. I'm just going to let this finish up. And we can turn that right up. So it brings almost no movements on the screen because it's fast forwarding it so fast. Okay, and it looks like we've got a pretty good part here. And I don't see any reports or anything like this. But you'll notice that I didn't turn on the collision checking, but if I do the deviation here, you'll see a big deviation here. So if we turn on the collision checking, this was the point of this. So so it basically shows you with the deviation here, but without even turning on so if we come back to the simulation and I turn on the collision checking back here, now we'll see this immediately come up. So what we'll do is we'll go back to the move list. I'll take this back to operation 4. So we'll just skip the whole program basically. And for the amount of time that it's taken, I mean, if you look at the number, there's 232,000 lines of code that is going through there. So it's quite a bit, and it saves you quite a bit of time because you can just fast forward to the end and see the results. This is what you want to see. So there's the whole complete part there. So this is the end. So it looks good now. So the one end, okay, so there is a problem, and you would get notifications of this as well if we were on play. It should stop. Okay, so there's the stop there. So now it's already saying it's more than 20,000. So it looks to me, if I just stop this and I just say no, it looks to me like we're cutting off the whole rad there. So there's a big problem with this tool. So now we can tell what tool it is, tool 4, and we can actually go. So I'll just let this run out so we can see the rest of it. So that side seems to be fine, no problem. It's only the one side that needs to be fixed. So if I back out of this, and if I've changed the program here because the ends here, I know what the problem is. I set it, so you'd see the collision and everything, but there's an axis problem here, tool axis. It's set to 3 axis. So if we set this to 4, it would automatically. So let's just see if I do this. So now if we do this, I wasn't really going to post the program, but let's do it. I want to show you on the fly that you can update and it's not trickery going on. You get to see the G-code itself. So we'll just wait a second for this to come up, and then it'll correct the program, and then we can run it and verify and verify that and make sure that its program is correct. So just wait for a second for this to come up. Okay, so there's our actual program that we have. So if I launch that back into IMSce, we don't really need to save anything or change anything here. We just need to repick the fixture and the stock and the model itself. So we can pick the fixture again. We'll pick the stock and the workpiece. And then we're just going to go right back into simulation. And that program should be updated now. And the nice thing about this is, like I said before, the simulation, if you know Mastercam simulation, there's not a whole lot of learning to do with this. I mean, you could just pick the fixture, the stock, and the workpiece. Wait for this to come up. Okay, so we've got all that. Back on. We've got our CNC, and I'm just going to turn on that tool number thing again. And we'll run through this. Because I know you guys don't want to wait for that, so we'll just skip to the end. Okay, and we can run that. And then the other side. Okay, so we can see, and I'll prove to you that there's no deviation. We didn't get any type of report coming back or anything like that. But if we go back here to deviation and we hit that, we can see it's green on this side and green on that side now. So the new CNC code that has a time in it of 1:46, and that's when it was posted. So that's the actual code that we've actually changed. So it's redone the program now. So you can see there's actually no trickery or anything like that going on. So one thing we could do too, if I take this block and I put a bad error in it, save that. So it's got the bad error in it. And we'll come back to this. We're just going to quickly run this through. So I'm just going to quickly screen pick these few components. We can come back to this and we can go straight into simulation. I want to show you that, prove to you that this is actually reading the G code. So when this comes up on the screen, we'll be able to read that Z minus 20 and then we can see it and we'll see the results of it too. Okay, so there's our part on the screen. And we're going to turn on the stock and we can watch the G code. And if we watch here, there's that minus 20 line right here. So we can just watch what's going to happen. And bang, you can see the collision right there. And of course, it'll automatically red X you right there. So you're well aware of what's going on with it. And I'm sure if we turn on the verification, the collision checking back here, you'd see that stop right away kind of thing. But I wanted to show you that that's the actual G code that we actually ran right from here. So there is no trickery going on. We are reading G code. So I wanted to make sure that you understand that there's not something going on in the background or something like that. So we'll just go on to the last demo now. This one here. So this one happens to be done in metric, and it's a DMG monoblock 85. So, and I've done a little cavity. Again, just a part I pulled, small little setup. I put a table here because it's the way the machine's set up. It's got the ball locks to hold the fixtures. So I didn't bother putting that in, but I wanted to make it look good and everything. So what we'll do is we'll just go straight into the verification of this. And again, you see that I didn't call anything up. All your stuff's sitting here already for you. The setup's already done for you because we've already saved it from the previous time that we were in here. So if I go back to origins on this one here, I'll point out with DMG, their origin system's not G54s, it's Q339. So again, and all I did was hit the defaults button and that came in for me. So I'm just gonna go straight into, we'll pick in the fixture and everything. We'll say okay to that, the stock, and then the workpiece. And we can say okay to that. And then we can just go straight into simulation. So you can see how easy it really is. I mean, it's really just the 3 things of information that you need to do. So if you do revisions to the program, it's not like you have to continuously change all the information or anything like that. I mean, if you're making changes to the heights and diameters and stuff, of course you would. But other than that, you can pretty much leave your setup the same. So we're just waiting for this to come up now. Now you can see it's a completely different machine again. It's the DMG. And again, it's the stuff's there. It's all in the background and everything. It's all there. It depends on how much details you want to put into it. I mean, and you can build the machines yourself, which is like fantastic. So in this one here, again, we're reading a different code now altogether. I'm just going to color the tools to the tool numbers, and then we can come back to the G code and we can just let that run. Get up there. And it might not be the exact path that I would do the actual cavity in, but I mean, I wanted to show you exactly, you know, and try to give you all the details of all the machining kind of thing. So you see that you can run through the G code itself. So we're just going to speed this up a tiny bit. There's your finishing or semi-finish. And then same, you can pull that up a little bit and you can see a little bit better. And then your finishing's happening now. And then I believe in this one, I did a leftover toolpath after this to get all the small little rads and stuff like that. So there's my tight little rads and everything. And that's pretty much the whole thing there. One thing I did notice with this machine is, you know, to swing in there and really see, it's kind of hard. If you wanted to see something on this face over here kind of thing, it'd be kind of hard because you're swinging it and you lose that track. just so you know and you're aware, we can actually come back to the machine and you can turn some of these components off. That can be set up as a default too. So if it's constantly getting in your way, you can turn the things on and off. It's not like it has to be on. So I just wanted to point that out to you. But that's the whole part now complete. And we can just double check that this is good, because we can go back to the analysis and we can go to that deviation and we can check that. Okay, and you can see it's all green. We're getting, and it's minus 25 because it's metric. So that's your 1 thou, between 1 and 2 thou. Here, and you can do this here, and we can do the gouge and excess. It's basically the same thing. It's just a different way of communicating it to you. So the different colors and stuff like that. But it shows you the deviations that you do have in the part. And there was one last thing that I wanted to show you here, verification. So with this gouge and excess report, so now it's actually showing a few gouges here, but they're very minimal. I mean, yeah, we're talking less than 1 thou here. And I didn't turn on the verification there, but this is like Mastercam gouge checking itself. And then again, if we go into this, we can apply the refine, and it'll apply that. So it goes through the move list, and then it'll get that picture so it's zoomed in. It'll be nice. It'll come out nice. So this is pretty much the whole overview of the IMSce. And I'm zoomed in quite good here, so it's taken a few minutes now to do this. Maybe I shouldn't have done quite so deep into it.
That's all right. We're doing good for time too, David. We're getting close to an hour, so this is a great, awesome demo. I was thinking maybe we could put a request in for audio on that crash. Scare the pants off everybody, and then you have to fix it, right?
Yeah, that would be, yeah, I've never thought of that. Well, that would really help.
It's a lot better than on the shop floor, that's for sure.
Yeah, exactly, right? That's what I like, the verification, especially the GCode, because it stops you from looking like an idiot on the floor, for lack of better words.
Yeah. So we still have quite a few people. I think we lost a few just probably 5-10 minutes ago, which is fair, because I kind of approximated 30 minutes or so, but
right.
You dove very deep on this, which I think is fantastic. It was great. It was a good summary for everybody to see. I don't see any questions here, but if anybody wanted to, if you did have any questions, you can raise your hand and I can unmute you. If it's easier to ask, over the microphone as opposed to typing something in, please feel free. We'll be here for a little bit. David's got this finite.
Yeah, it's still working away.
So I've
obviously gone in pretty far.
Yeah.
I apologize. I shouldn't have gone in quite so
that's
far.
Okay. That's all right.
But if you wait a second, yeah, it'll come up.
Yeah. So we've got a question here. Let me just have to expand my window a little bit. So yeah, it says, can we input our own machines? That's from...
Absolutely, you can. You'd need to make your machine, or you could buy one.
Yeah, but you can do it as long as you have the control family. So yes, the answer is you can create your own machines.
Yeah.
It's quite a bit to it. Obviously, that's something that we would provide for our customers, that whole as a whole solution. But it is possible. No problem, Dave. Anytime. I guess I could also just throw out there to anybody, obviously, if you have any questions on anything, by all means, you can email me, you can email your rep, and we'll certainly get you an answer. If you, would like to see it more, I would, a great suggestion would be a more in-depth demo on your specific parts and machines. By all means, we can set that up as well. More of a one-on-one situation, which is always better. We would certainly do that at any time for anyone that's interested in that. I will, like I said, I will have this recording. It will take a while to compile, but I will have a recording of this. If anybody wants that as well, just send me an email and I can send it out. Other than that, I think, David, you covered it very well. I like
Yeah, that's pretty much it.
different machine configurations. It was great for everyone to see.
That's why I knew that you had requests for different machines, so that's why I wanted to make sure there was at least 3 different machines there. So
Yeah.
make sure that that was showing up, and the multiple origins. I knew that was going to be a question if I didn't address it, so that's why I wanted to do that right up front.
Yeah. Okay, we've got another question here from Scott. Will it identify an over travel?
Yes, it will. I think I'm stuck on one of these now.
Yeah, you may have to cancel a few.
Yeah, I think so. Because there's one here. This one here actually does have an over travel in it. I'm just wondering, because I've got so many windows open now, I'm just wondering if we can get into it now. But I'll try. Let's try this. Yeah, I've got it going to a couple of them now. See, I'm not sure exactly what's going to happen. Okay, yeah, okay, it did.
Yeah, over
good.
travel.
Okay, so now I turn this on. It's okay to that. You just let this run. I think there's one in here if I still got it. Okay, yes. So here's your over travel here. So there's a y-axis overrun, so you can see exactly what's going on. I've gone way too low. I mean, it's not getting a collision because you're actually over traveling the y, so you're not getting into collision yet. That's why there's no collision. But you can see where it's actually starting, and again, that'll relate back to the NC code itself. So you can see the exact move that it's happening on, let alone the over travel itself. But you can see the exact move. And again, it actually caught it twice because there's 2 finish passes on that. So yeah, it does show over travels.
So we have another question. Will this be available for mill turn? Short answer is yes. Maybe it would be more accurate if I say maybe. We have actually already set up a bit of a mill turn simulation for a customer of ours in Quebec, and it takes a bit of work, but it can be done. And I think we kind of, with the situation that we had in the application for our customers specifically, we sort of forced IMS's hand a little bit in that regard. So short answer is yes. Ideally, we would want to investigate your exact machine and exact application before we sort of gave a yes, it can be done. So a bit of a gray answer, Holton. Sorry about that, but by all means, let's chat afterwards and we can investigate that. Ultimately, Mastercam 2024, I think we will start to see more and more of the mill turn machines, but it will take a bit of time, and probably, I guess it'd be fair for me to say a bit more work in terms of the setup and things like that. So I hope that answers your question. I know I'm not very firm there, but it's one of those gray areas right now. So, I think we're good for questions. We still have a few folks here, but I think as far as it goes, I appreciate everybody's time here and sticking with us for just over an hour. And hang on a second. How much? So it really depends on basically so as I was talking on the controller families, it's sort of you buy the license or the seat of IMS and then you buy per controller family. So I can't say exactly what it would be, but I can depending on what you're looking for, we can give you some ballpark pricing, Scott, and we can take that offline. But if I was to give an approximate sort of setup, an average setup, if you will, you'd be somewhere around 20 to 25K for a setup and the one controller family. That also includes 1 year of software maintenance as well. And if I'm not mistaken, I think it was 1 or 2 days of training, or setup and training. So not bad. And, obviously it could be a little bit less if we didn't need to do the training and there wasn't a lot of configuration going on. So that was, just an example.
Yeah, I wouldn't think there would be a lot of training if you knew the simulator already. So if you're a seasoned to using the simulator already inside of Mastercam, the training for this would be minimal.
Yeah. And yes, that is in Canadian, Scott. One more question here. Will the post development team be utilizing this to ensure that new posts are a little more polished and need less time holding up production, getting the posts right? I think that valid question, and I think that would be the intention moving down the road. They already have sort of checkers and things in place for that for QC, but this is a good tool for that as well, Holden. So. That's great, David. I really appreciate it. And thanks everybody else that's still with us. Thanks for joining us. And like I said, reach out if you have any further questions and we can dive deeper for you.
Thanks for joining us today.
Yes, absolutely. Thanks for the demo, David.
Yep. No,
Take
anytime.
care, everybody.